So you used to work in advertising technology and neuroscience. Can you explain a little bit about how that relates to work in the public accounting industry?
Yeah, definitely. Whenever people talk to me about kind of my background, it seems like I've done very different things, everything from, biology to kind of advertising technology to now public accounting. But really, there's been three underlying areas that have stayed the same throughout this whole process, and it's really this combination of taking data, applying math to it, and then using computers to kind of do that at scale. And so, along the way, everything has, when I studied the brain, it was really, the brain has trillions of synapses of connections in it, and you really need a lot of high powered computing to do that. When you think of online advertising, there's billions of cookies on the web, and you need advanced computing to process that as well. And so really kind of the ingredients in all of these spaces has stayed the same. And just to make some specific kind of comparisons here, in ad tech, we would have this question where it would say, given someone's website history via a cookie, what would be the best ad to show them? Is this the kind of person who wants to buy high-end men's clothing, or is this the kind of person who would rather just kind of buy beach sandals or something like that? And so there is that question there. In accounting, we might have a question though, given these numbers on a form, or given this data on the form, we want to reclass a field. So it's a K1, and we know that someone is writing something. We want to reclass it. What should we reclass that to? And so in both cases here, we're taking a lot of data. It's either your web history or the data that's written on a K1 form. And we're trying to make a decision based upon that, essentially put someone into a category. Either say this is the kind of consumer they are, or this is the kind of data entry that appears on this K1 for reclassification. And so they seem like very different questions, maybe at the onset, and they're in two very different verticals. But the methodology underneath it stays the same. And a lot of the techniques in ML, kind of math and science that's been developed for these problems has stayed exactly the same between these two realms. Another kind of fun one, example kind of in the same realm is in neuroscience. A lot of the ways that you can look at the brain is there's a lot of different cells, and they're all connected to each other, and it's kind of this jumble of wires. And so what you often use in neuroscience is the idea of graph theory, where if you think of the brain as kind of a graph where certain processing's happening here and memory's happening over here, and maybe senses, you're smelling something over here, and how those things connect, there's a lot of math around that. And so what we've actually been doing lately at SurePrep is some really cool work around understanding how different documents relate to one another. And so when you're thinking of a binder or a tax return for a year, you can actually think of it similar to a graph of, if you have this document, you might also have this document. And if you had these documents last year, they would also create a similar pattern, and you can look for commonalities between the graphs. And there's a whole branch of mathematics called graph theory, which turns graphs into really simple, or not simple, it turns graphs into really just a complex, interesting way of looking at data and making more kind of conclusions from that data. And so again, it's something that I hadn't worked on since my days in neuroscience, probably over 10 years ago, and it's starting to creep up again in my daily work here at SurePrep, which is really, really interesting.
Yeah, that is interesting. Graph theory, is that what's called? It's totally new concept to me.
Yeah, graph theory, and it comes from actually super old school. I'm trying to think of what year it was. People were trying to understand how you can make like the least number of bridges in a town over a river, and try to figure out like what is the right routes and stuff like that. So this theory dates back hundreds of years, but we're using some of that on work today.
Very interesting.